Okay. All right, go ahead.
Are we ready?
Yeah.
Yes.
Can you back up to slide 1, please?
I believe that's it.
There you go.
Okay. Everybody on board. All right. Hi, everybody. This is Tom Schoen. We'll get into a little bit of me here in a couple seconds. But I want to introduce the panel that's going to present Maxim 3D tonight. Leading off the thing, doing most of the heavy work is Dr. Alex Gibberman. Dr. Gibberman's in Cincinnati, and I've known Dr. Gibberman for what else, about 10 years now?
Oh, probably close to it.
And he's definitely quiet about this, but he's on the cutting edge of scleral lens technology. And we're happy to have him on board. He's been fitting Maxim 3D for a couple of years now. So welcome, Alex. I'm going to turn it over to him in a couple minutes. Next up is Steve Cogger. Steve is Director of Product Engineering at AccuLens, fellow of the Contact Lens Society of America, and an all-around great guy. And Elsa Masler, VP of Marketing. Her dad started the company a whole bunch of years ago. We'll give the number here in a second. I think it's 71. And she's doing a great job of sales and marketing. Troy Miller kind of heads up all the nitty gritty stuff behind the scenes, manufacturing lenses, getting ready for new designs, production, the whole 9 yards. Troy, I hope I didn't understate your role too much. And then Tom Schoen, I think some of you guys know me, but I've had a decent history in the contact lens field. I was at Cooper for 20 years, then Alden with 5 or 6, and then jumped over with Eaglet, and now I am consulting with AccuLens and loving every minute of it. So thank you, team, for letting me get involved with your lab. Okay, can we jump to the next slide? It's a little more deep dive on, go up one, a little more deep dive on Dr. Gibberman. He's got his BS, unfortunately, from Penn State. I'm a Syracuse guy. Then he went to PCO to get his OD. He's been in private practice for 6 years. He also is a fellow. This is with the Scleral Lens Education Society and the AAO, so he's got his chops in order, and he's definitely into scleral fitting. So with that, I am going to turn it over to Steve, and then Steve will turn it over to Alex.
Great. Thank you, Tom. And thank you, everyone, for joining us tonight. A little bit about AccuLens for those of you who are not familiar with us as a lab yet. We've been around since 1971. The lab is located in Denver, Colorado, and we really have been specializing in GP lenses for quite some time, and scleral lenses for, I'm going to say I think the Maxim must have come out about 15, 16 years ago, because I know when I joined on, they were already on their 3rd or 4th version of the Maxim lens back then, and that was 15 years ago. So certainly has been involved in scleral lenses for a very long time, one of the early innovators, and the design has changed quite a bit over the years. And today we're going to talk about the Maxim 3D design. What we tend to do is we really do combine the cutting edge freeform scleral designs with the flexibility of trial fitting. So we have a few options, which Dr. Gibberman will get into on the actual fitting process and how we do it, whether it be with a fit set or not. And the materials we're using, mainly the Optima materials. So we've got Optima Extra and Optima Infinite, both very high DK. Optima Infinite is a 180 DK lens. It's very stable on the eye, has very good wettability properties. It's also HydroPeg compatible, so we can include that. The options and materials are great, and then we can just jump ahead there to the precision in manufacturing. So we have DAC lathes. We have multiple lathes. I believe we're installing a new one as we speak, because we're just growing and really focused on, again, the precision in design. So the combination of using the modern DAC lathes with our focal point software is really what allows us to combine our freeform algorithms and design into precision in manufacturing. So we're at a really great spot with that right now. And again, that digitally designed aspect, by using CAD programming to come up with a precise lens for each patient. And you'll see as we move ahead in this presentation. Our concept is not so much that we just have a lens and we're going to send it to you for a patient. The concept is we have our baseline lenses, and from there we want you to be able to customize pretty much anything for each individual patient. So every lens that you get for each patient is going to be unique to that particular eye based on what you're seeing and what you can tell us, or whether what equipment you might be using to create that. So the freeform definitely goes beyond just creating a design. We want to mimic the shape of the eye and give you a complete custom option for each individual eye for your patients. And with that, I believe Dr. Gibberman, you're going to take over from here and talk more detail about the lenses.
Thanks, Steve, and thank you everybody for joining this evening. Guys, everybody, this is a ton of fun for me. I started practicing optometry 10 years ago, and about 6 months after I started is kind of when I dove into scleral contact lens fitting. Didn't have much at all experience with it in school, so I was pretty green, pretty new, and actually, Steve Cogger was the one about 9.5 years ago that flew out to Cincinnati and pretty much gave me the crash course training into scleral lens fitting. And then here we are 10 years later, and it has been absolutely awesome every step of the way. So thank you, Steve, and thank you, AccuLens, for getting me up to speed. And it's been a really great company and a really great lens to work with all of these years. And I think the one word that comes to mind for me with AccuLens and the Maxim 3D is versatility. So, for example, when I first started, I did not have any of the bells and whistles. I didn't have any of the fancy equipment. I pretty much just had slit lamp, fluorescein, and the trial lens set, and that was perfect. That was everything I needed to get started. And, it's been really fun over the years to grow in my knowledge base, and also just with AccuLens and all the technological changes that have happened over the years. And it's been a lot of fun to be a part of that. And then about 5 years ago, a buddy of mine and I started our own private practice with a focus on fitting scleral lenses. And now we do have all the fun bells and whistles. We have OCT, and we've got the Ovitz HOA correction. We've got scleral profilometry, and it has been very nice to not have to switch lenses, not have to figure new things out. AccuLens has really been on the cutting edge of that technology every step of the way, and has really worked hard to continue to improve their algorithms and make sure that their technology is in line with what's available. So let's just kind of start by looking at the trial set and what is included in that. So it's pretty straightforward. You've got two diameters, a 15.9 and a 16.4. There's 6 lenses with different sagittal depths, different base curves of each. And that really is pretty much all that you need to get going. And we'll talk and we'll look a little bit more at the specifics of what's in those trial lenses as we go here. But if you don't have all the bells and whistles and you're just working with the trial lens set, probably the most important measurement that you will need is the HVID, because that's basically how their lenses are set up. If you know the HVID, you can pretty comfortably add about 4 millimeters to that, and that's the diameter that you're shooting for. Since the trial lens set is a 15.9 and a 16.4, we pretty much use 12.0 millimeters as our guide. If the HVID is 12 or less, we're going to be using the 15.9 set. If the HVID is 12.0 or larger, we're going to be using the 16.4. And really remember, that's just a starting point. I would highlight that one of my favorite aspects of this lens is how customizable it is. And one of those parameters that you can adjust is the diameter. So like, for example, there's a lot of great companies, a lot of great lenses out there, but one of those parameters that a lot of times you cannot change for other companies' lenses is the overall diameter of the lens. You're kind of working within that shell. But in this case, sometimes the only change that you may want to make is to make the lens say 0.1, 0.2, 0.3 millimeters bigger or smaller, this lens, AccuLens, gives you the ability to do that with the Maxim 3D. So we're going to talk a lot more about all the different things that this lens is capable of: front toric, back toric, offset optics, freeform, by the clock hour, multifocal options, microvolt, etc. So we're going to go through all of that in the next 45, 50 minutes. And then I'd love to leave some time at the end for some questions, as I'm sure there will be some questions as we go. So yeah, what can be done? What can be done? I just highlighted the diameter change, which I think is definitely a nice highlight of this lens. I would say that probably the best thing is that none of the changes that can be made are mutually exclusive. So you know, it doesn't matter if you're using a multifocal with offset optics and you have residual astigmatism. You can still put that front toric on there along with the freeform back surface. If there's a vault needed to go on there, all the bells and whistles, all of those things can go in, and all of them at once. None of them are mutually exclusive of one another. So let's take a look at a couple things that are on the actual trial set of lenses, because this is unique to AccuLens and the Maxim 3D as well. So when you take a look at the lens, and when you look at the lens on the patient's eyes, there's two sets of markings on the lenses. The first set is the limbal curve indicators. And I would say, especially if you are in the category of a newer fitter, you know, for me, this was super helpful towards the beginning. This lets us know, do we have the right size lens? And so if you have done this correctly and you've chosen a proper sized initial trial set lens out of the set, what we're looking for here is to see the limbus basically going through the A and B hashes on those limbal indicators. That indicates to us that we have a proper amount of or adequate amount of limbal clearance, and that the overall lens diameter is not too small. If the limbus is slicing going through B and C, or certainly if it's outside of the outer indicator that we have labeled C here, that would be an indication that the initial trial lens is probably too small and that we would like to go with a bigger one. So that's just kind of a good check mark in the beginning. I think as you go and you get more familiar with you know, fluorescein stain patterns, and certainly if you have some you know, OCT technology and other things, there's different ways of looking at this. But as a quick way to check it on the eye, this is really a useful tool. The other set of markings that are on the lens is what's called the OnPoint system. So this is what we would use to measure alignment if we're fitting a multifocal. And this is also really a useful tool, because as we know, scleral lenses tend to decenter often inferiorly or inferior temporally. And this takes the guesswork out of how much that lens is going to misalign. So this gives us a system to measure not just the amount or not just the direction, but also the amount of that decentration. And the way that this works is, once the trial set lens is on the eye, you'll let it settle for a few minutes, and then you take a look at the number of hashes that are inside the pupil. And you're recording whichever meridian has the most number of hashes completely inside the pupil. So if your lens is decentered a certain direction, in this case, in the 45-degree meridian, there are 4 hashes that are inside the pupil. So that you would record 4 hashes at 45 degrees. And then if you're utilizing a center near multifocal, the lab is then able to recenter the optics to better center over top of the pupil. And that's super helpful for obvious reasons. The multifocal zones are pretty small, right? We're talking 2 to 2.5 millimeters. I think 2.5 is the standard size multifocal zone that they're using. So if that lens is decentering even a little bit, that patient's not going to be able to take advantage of that full add power. So keeping in mind that, you know, the trial set of lenses is already a back toric. So there's already a toric periphery included in your trial set. So, hopefully that lens is going to be decently, centering already. And we know that when we make adjustments to the mid-peripheral and peripheral curves, that the lens may rotate a little bit and that the lens may center a little bit better with that final lens. But in general, the decentration is still going to be pretty true. And we found that with our multifocal patients, this has really been a helpful tool to guide the exact direction of that decentration. As a matter of fact, we've gone back and refit patients that we had in multifocals years ago before the OnPoint system was a thing, and then we actually refit them with the decentered optics, and a lot of those patients had improvements with their near vision. So in a nutshell, it's a really useful system. I do want to point out that this is specific to the center ad multifocal. AccuLens has a couple different types of multifocals, and we're gonna look at those here in a moment. My mouse and keyboard stopped working. Okay, so I think I mentioned this earlier, but the multifocal and the offset optics is not mutually exclusive. So if you have decentered the optics and you have residual astigmatism, you can still incorporate that front toric into the lens, and it works really nicely. And if you needed to add a vault or something like that, micro vault somewhere along the edge, also can be done alongside these multifocals. So a lot of fun options to play with there. I think that one of the things that also sets the AccuLens, the Maxim 3D apart is their profile of multifocals. So there's really two main types of multifocals that I would highlight. The first is their distance-centered aspheric multifocal, and that is probably more useful for your early to mid presbyopes, with thinking of that as more of an intermediate lens, maybe a max add power of a +175. And then the other is that center near multifocal, which really doesn't have a limit for how much add power that you can put into that. Those are the two main options. They also offer an alternating multifocal. So if you're not having success with those first two options, that is kind of a fun third option to play with. And then again, reiterating that if you're taking advantage of decentering that the multifocal, you're using that with the center near ad. As we all know, right, we're all used to working with multifocal patients, similar with soft lenses. It depends on the patient needs, right? I think for me personally, if the patient, and this is again kind of an estimation, 40 to 47, 48 years old, I'll use an aspheric multifocal in both eyes, unless they have very, very specific near needs. Your plumber, your painter, your teacher, your accountant, someone that's really working a lot up close. 48, 49 and up, I won't necessarily go to a center near lens in both eyes. I kind of like using an aspheric lens in the dominant eye, and I like using a center near lens in the non-dominant eye. I think that to me gives a little bit of a better range. That way one eye has an add power for more of an intermediate focus point, and then the non-dominant eye has a focus point for more near vision. But certainly the exception to that would be if the lenses are decentering significantly. Even in a younger patient, it's more beneficial to recenter that multifocal zone. So then that might be a time where we would use a center ad in both. So skipping ahead, what makes a lens freeform? So, when I started fitting lenses, the options were good, but they were a little bit more limited. We were looking at front toric and we were looking at back toric. We kind of thought of the lenses as far as two meridians, right? A steep meridian and a flat meridian on the sclera. But as we learned and certainly saw with a lot of our imaging technology, that certainly does not apply to everyone or even most patients, which for most people, especially our irregular cornea patients, a lot of those folks have asymmetric or oblique scleras. And so it was a huge jump in the right direction when we went to the quadrant specific lenses. And then it was another leap forward when we had the ability to go to the freeform lenses. And to me, you know, the freeform just basically means we can be that much more specific. We don't always need it, but certainly when we do, it's nice to have that option to basically be making adjustments in clock hours as opposed to in flat and steep meridians, or even just as far as quadrants. And I think this is you know, certainly very useful when you have elevation changes on the sclera that are maybe just in one spot. You know, something that's bigger than, say, a pinguecula that a microvault maybe can't handle, where it's a larger elevated area. Or the other time that this is really useful is when these changes are not 90 degrees or 180 degrees apart. You know, maybe you have an elevation or a depression at 11 o'clock, and then you have another one at 3 or 4 o'clock. So in a traditional, you know, toric periphery or quad specific lens, you're going to be off a little bit, or you're going to be over or under correcting a too wide of an area. And so these clock hour specifics are really, really helpful as far as alignment. But it's not just the periphery. It's not just the edges that we're looking at. One of the other things that we've learned along the way, especially when we're talking about decentration, is it's not just the periphery. It's not just the peripheral curve landing on the sclera that is, you know, that has toricity. It's also often at the limbus. And so what AccuLens has done with the Maxim 3D is they have designed what they call a smart curve. And that smart curve actually starts inside the limbus and it just outside of the optic zone. And that pretty much allows you to make changes essentially anywhere. So if you have a patient that has a really toric limbus, and we've learned a lot about this using the eaglet and the eye surface profiler, and we'll take a look at that shortly, but where you can set your measurements to looking, say, at 13 millimeters at the limbus. A lot of times the limbal curves are not spherical, and that's the reason that the lenses are decentering. And so it's really helpful to be able to make not just the peripheral curves freeform, but the limbal curves that way as well. And that's been a huge step forward as far as centration. It allows us to make the lens pretty much any shape that we want, prolate, oblate, or just straight up funky. As I mentioned, all of the trial lenses are back toric. The toricity that's built in is 200 microns. So essentially there's a steep meridian that's 100 microns steeper. There's a flat meridian that's 100 microns flatter. And when you put that lens on the eye, it should rotate. The dot will be placed at 6 o'clock, and that dot will rotate to the steepest part of the eye. And that is really, really important to record that. I would say beyond the noting the HVID and your other measurements, forgetting to record where the star ends up is certainly problematic if you're making freeform or very specific changes to the back surface. Certainly if you're incorporating a front toric onto the lens. If you're sending the lab images, they can estimate that rotation, but it's really nice to have a lens on the eye, see where it settles, and it's usually going to settle pretty quickly, usually within a couple minutes. And if you want to double check it, an easy way to do that is just with your finger to rotate it back to 6 o'clock and make sure that it's settling in the exact same spot. A question that comes up a decent amount is, are we incorporating front toric out of the gate, or are we waiting for that first lens to come back? Personally, unless there is something extreme going on with the eye, because that trial lens is already a back toric, you know, unless, again, if we're making a lot of extreme changes, we may hold off. But if we're just tweaking things a little bit, I'm usually pretty comfortable putting that front toric in right out of the gate. And 9 times out of 10, I think we're pretty spot on with that final lens rotation. And the other thing I would note about this is you're noting where that asterisk is rotating with the trial lens. However, when the final lens comes back from the lab, they will then offset that asterisk and it should be sitting back at 6 o'clock. So as the practitioner evaluating the lens on the eye, that's kind of the way that you can double check to make sure that the lens has rotated in the way that you expected it to. So I think that's what we just talked about there. We're going to skip ahead to, when we, again, I would say the other thing I just want to reiterate is there's really no limits as far as prescription, amount of toricity, changes that can go into this, maybe with the exception of some of those extreme blebs, right? That require maybe a little bit more of a molded type fit or something like that. But for the most part, the Maxim 3D AccuLens, their lathe cutting, they can pretty much handle just about anything. And it's really nice having that diameter adjustment as well. So, if there's ever a time that I have a question of, hey, is this outside of what they're capable of? I'll still just assume they can do it, and then I'll call and ask their consultants or Troy, and he'll let me know if it's something they can or cannot do. But for the most part, if you can think it, you can pretty much put it into this lens. The other part of that I would highlight is the microvault. So I think for some folks, I think we're thinking that microvaults, or what we call it, the AccuVault, is really, a lot of people assume that's just for the peripheral curve or just for the periphery of the lens. That vault can actually be placed pretty deep into the lens. You just want to avoid putting it in the optic zone for obvious reasons, but if you have a patient with a pterygium or some type of growth or a Salzmann's nodule and you want to vault that internally inside the cornea, you can actually do that. And that's a really nice feature of this lens as well. So before I get to some of the scanning technology, I just want to quickly roll through a couple cases that highlight some of these features of the lens. This first case, this patient, pretty straightforward overall, a relatively healthy 74-year-old female with significant dry eye, but otherwise pretty regular corneas. Wasn't having a ton of success in soft lenses between optics and the dry eye, and wanted to go with the scleral option. So couple things to highlight. This patient, overall pretty good vision, 20/25 plus 20/25 best corrected vision in glasses, not a ton of astigmatism, some mild cataracts, but the right eye had an HVID of 11.8. So with that HVID, we would be selecting, in this case, the 15.9 diameter. I think we have that mislabeled there, but it's a 15.9 diameter trial set lens. And because the right eye was the dominant eye, we elected to go with the aspheric multifocal for starters on that side. And then the other eye being a 12.1 HVID, this would probably be an example where we may not necessarily want to go all the way to a 16.4, but I think as far as a trial lens set, you would be okay to use the 15.9, evaluate it. You could look at the limbal curve indicators and see exactly how close to the limbus those curves are and what that limbal clearance looks like. Certainly wouldn't be wrong to put the 16.4 lens. If both eyes were over 12, I would certainly be starting with the 16.4 trial lens, and then having the option to make that lens a little bit smaller if we wanted to. So that would be the one thing to highlight on that left side. The left eye was the non-dominant eye, so we went with a center near multifocal with a slightly higher add power on that eye, and just noting that the star rotated about 40 degrees counterclockwise. So I think in this case, again, we did end up going with and I apologize, I think we have that a little bit mislabeled, but I think it was a 15.9 on the right eye, and I think we ended up going with a a 16.1 millimeter diameter on the left. And this patient inevitably was really happy with those optics. Multifocal optics, if your patients are new to multifocals, keep in mind that I think there is definitely a degree of neuroadaptation. So we get a lot of questions, should I ease into this? I would actually say the answer is the opposite. The more the patient wears it, the better. And the more that their brain can kind of get used to and adjust to those optics, the quicker they will likely kind of neuroadapt to that vision. So I think, and giving them a chance to try it, it's rare that someone just says they hate it right away. We'd certainly encourage people to try it for a week or so. And then if they're struggling, then we may figure out what those complaints are and make adjustments accordingly, whether we need an over refraction of added plus, or if we're going to maybe switch up the type of multifocal in one eye or both. Second case, looking at a severe cone patient. On this patient, the main thing I think I would highlight here is the HVID. So on top of the fact that they have keratoconus, right eye being 12.8, the left eye being 13.1. If you were to put a 16:4 trial lens on the eye, as we did in this case, the lens still wasn't big enough. And so, in certain, other companies' lenses, if we were only reserved to that one specific diameter, we might be in trouble, or we might be able to increase limbal clearance, but it may affect kind of how the overall lens fits, centers, how the edge profile is looking. So it's nice to sometimes keep things simple and just simply overall make the lens bigger. And so we were able to do that in this case, and it worked out really nicely. So our final lens diameter in this case was actually a 17.1 in the right eye and a 17.4 in the left. Utilized some higher DK material, and this patient also had some pingueculas, so we were able to take advantage of the AccuVault and vault over top of that as well. So let's move along and take a look at how we use profilometry. So I mentioned in our practice, we use the eaglet, the eye surface profiler. It's a great instrument. And even if we aren't able to get perfect data on every single patient, I still try my best to get at least a scan on every single patient, because there's still useful data to be had there. Even if you can't get it perfect in every quadrant, of course, we have those patients with tight lids or that are squirming and squeezing, and for one reason or another, just can't get those perfect fits. Still really able to, at the very least, you're getting a very accurate HVID, and you're probably going to get at least a couple quadrants idea of what that scleral topography looks like. AccuLens is also compatible with the Penacam. I can let Steve or Troy talk about that in a little bit, but I'll focus on the eaglet since that's what we're using in our office. And super simple, super easy to use for those that are not quite as familiar with it. I'm sure everybody's at this point seen it, heard of it. But if you hadn't had a chance to play with it, I certainly would recommend it. It's really, really user-friendly. It's really easy to use. We learned it really quick, and it has absolutely 100% cut down on the number of follow-ups, because in those, whether it's an extreme case or not, really in any case, but certainly in the extreme cases where you have a lot of scleral asymmetry, it takes the guesswork out of what we're doing. The actual image acquisition process is super easy. It's like taking an iPhone photo. It's very quick. It's done in central gaze. The only catch you're using, you have to put fluorescein in the patient's eye. It does work on reflection, and I highly recommend having someone, a staff member, hold one lid and you, the practitioner, holding the other. That is absolutely the way to get the best images. It's very tempting to have the patient reach around and try and grab their lid. Patients will often try to do that. They'll try to be helpful. You're always going to get better data when you follow the appropriate recommendations, and that would be having two people to hold lids. But again, I think if we take a look at the image guided fits that we've done kind of before and after we started using this technology, most of the adjustments now that we're making are prescription based and not necessarily fit based, because we're able to be so specific as far as what we can order and what we can send to the lab. In our office, and I know everybody does this a little bit differently, for me, my process is pretty much this. We're going to get an image, again, on every single patient that we can. Depending on the quality of that image, we then may or may not send that to the lab for them to utilize. But AccuLens, really, even if you send them half the data or multiple pictures and piecing it together, they're able to create a really, really good idea of what that eye looks like and what that lens looks like, because they can input that directly into their CAD/CAM software. I like it because I pretty much know what that trial lens is going to look like on the eye, even before I put the lens on there. And as an additional bonus item, the software actually will calculate and it will tell you which trial lens to select. So it's not necessarily giving you the final parameters of the lens, but it's giving you the best or closest fitting trial lens set in your case. So again, it depending on if you're the one doing this or if you have a staff member that you've trained to do it, it in that instance would give them the capability, assuming they've gotten a pretty good scan, to basically go into the room, select the correct trial lens, have the patient put it in, and then it's already in there and waiting for you when you walk in to evaluate. So again, depending on how your office is set up, there's a lot of really kind of nice options there that you can utilize here. And then again, for me, it really just takes the guesswork out of it. And the more familiar you become with the technology, the more things that you realize there are to play with. We mentioned limbal toricity before. You can basically set the cord length to whatever you want. So if you know that you're working with a 16.4 millimeter lens, it's really nice to be able to set those measurements at 16.4 and start looking at things around the sclera at that exact spot, because you don't, even though the machine may be telling you data all the way out at 18 millimeters, if you're not using an 18 millimeter lens, you don't really care what's going on at 18 millimeters. You may care a little bbit more about what's going on inside, but it's really nice to be just that much more specific. So in this third case, again, we were basically, we had an advanced cone patient. We were utilizing the scan data to design this fit, and taking a look at this scan. For those of you, again, that are either not familiar or not super familiar with what we're looking at here, there's basically two scans inlaid over top of one another. The center circle, that's kind of inside the red zone here, that's the cornea, and then outside of that red zone, the limbus, is the sclera. And those are kind of two separate maps called a bisphere map that are inlaid right on top of one another. And keeping in mind that this is not a curvature map, but it's an elevation map. And the blue areas are indicating areas that are lower than the best fitted sphere, and the areas that are red are areas that are higher than the best fitted sphere, and areas that are green or yellow are more along that plane of the best fitted sphere. And so I can't do this with my cursor because we're not in the software, but if you're actually using the software, you can hold your cursor over top any area inside of here, and it's going to give you specific micron depth data. So you get a pretty good idea, even without looking at what's automatically calculated for you, that you can see that in this case, this is a very with the rule eye, right? It's going to be steeper and more depressed at 12 and 6 o'clock. And then we have this big elevated area at the nasal quadrant. Maybe that is a large pinguecula. Maybe it's just an elevated area of the eye. That's something that we need to look at the actual eyeball of the patient to determine what that is. But certainly this map is telling us then exactly where those depressions are, exactly where those elevations are. We're then able to see exactly how wide they are, how deep they are, And that information can be sent directly to the lab with one click of the button in that Direct Connect software, which makes it really, really convenient. And then you're not necessarily having to convey all of this over the phone to a consultant, but then they can see exactly what you're seeing. You can put the trial lens on the eye and see, is this real? Is this what we think it is? And 99 times out of 100, it's pretty darn accurate. And so again, just a ton of wealth of information here that takes the guesswork out of this. This is a great example where, you know, if those depressions are 500, 600 microns deep, and we only have 200 microns of toricity in our trial set lens, those meridians at 12 and 6 are still going to look really, really flat on the eye, right? Those edges are going to look flat when you put the lens on there. And furthermore, depending on how elevated that nasal area is, the lens also may be just sitting even higher if it's rocking on that elevation. So you've got a lot of things. If you're looking at the trial lens, you're probably going to end up having to order a number of lenses because you're telling the lab, well, gosh, it's pretty flat here. I don't know exactly how flat, but I think I'm going to guess it's 2 steps, right? And in AccuLens terminology, 1 step of change, whether it's 1 step tighter, 1 step flatter, is about 70 microns. So, you know, we may say, well, we think we need to tighten this 140 or, you know, 2 steps or 3 steps, but it's really a guess unless you have those exact numbers. And that's where this technology really can cut down a lot of those follow-up visits. Similarly, if it's not a perfectly with the rule eye, maybe you just have one specific area that is, you know, the eye is overall pretty spherical, and you just have one area that's slightly depressed or very depressed. Same thing, you're kind of taking the guesswork out of it. And this is a good example of a scan where we're missing some data in that inferior nasal quadrant, and that's okay. The lab, to a degree, if need be, they can extrapolate what they think that area might look like. We can probably guess, right, that it's going to be similar to, you know, where it is 180 degrees away from that. But you know, for the areas that are present in this photo, still gives a lot of valuable data for the same things that we just talked about. We now know exactly where those depressions are. They're not perfectly at 12 and 6, but they're rotated, say, you know, about 40, 45 degrees in this case. And we can be very specific as to where we want to make those changes. When we think about freeform and all the things that this lens is capable of, I think I would go back and even reiterate, it's really nice to be able to do it. But sometimes you don't actually have to. You know, if this area turns out to be pretty small, and depending on the diameter of the lens, maybe we're using a slightly smaller diameter lens, and it's just really barely touching that inferior temporal depression, we may actually end up overall doing pretty well with spherical back surface lens and only really accounting for that pinguecula. So that's the advantage of still putting a trial lens on the patient. That's the other question we get sometimes. You have these scans, do you even need to bother putting that initial lens on the patient? I personally feel it's always valuable to not just have computerized data, as great as it is. You still want to have that lens on the patient. For the very least, you're getting really good over refraction data. And so that gives you the best chance of getting that one and done fit. But also I think it gives the patient the experience of seeing what does the lens feel like roughly, right? We try and tell them this is not your lens. It's close, but we're going to be making some changes. And usually, you know, especially for patients that haven't really experienced or seen scleral lenses before, they see the giant dinner plate that you put on your plunger and they start, you know, they start sweating and you're like, oh my gosh, that's not going to feel comfortable in my eye. And then you put it in their eye and they're like, is it in yet? And you know, you have that special moment with the patient where they can see. You know, I still think that's immensely valuable, right? To have that interaction experience, kind of show them what's going to happen. But it also allows for a check on this data, right? So this is that example. Do we need to make that very kind of, you know, clock hour specific adjustment to the lens, or are we going to be fine just keeping it simple and maybe just accounting for the pinguecula in this case instead? So again, the technology is amazing, still really good and important to put a trial lens on that patient. Let's see. So just some other examples, looking at these scans, different things. Again, we're able to account for clock hour type changes. I don't think we have any other specific eaglet eye surface profiler slides in here after this, but basically the way that this works is once you have these scans in there, you're taking a look at the HVID. So that's something that it will calculate for you, and then you're going down and you're clicking the button that says AccuLens, and it allows you to select the diameter that you want at 15.9 or 16.4, depending on that HVID, and then it's calculating the trial lens that's going to best be suited for that particular patient. And then when you're ready and you click submit, it's going to give you a form that pops up that basically populates all of this stuff into that form. And then all that you have to do at that point is type in any other notes that you may have noticed from your trial lens, the over refraction. If you want to put a multifocal or any other types of changes, you click send, and then that data goes directly to Troy or whoever else at the lab. And then they're basically working with that data from there, putting it into their software, and the rest is history. So the last thing that we're going to talk about, and one of the new kind of exciting things that AccuLens and Maxim has brought on board, is their capability to work with HOA and the Ovitz. And I guess before I let's do this. I'll talk about kind of my process. We actually just got our Ovitz in the office a few weeks ago, so we've been looking at the technology for a long time, but we just pulled the trigger on it. We actually just redid our office a few months ago, so we had a lot of moving parts and space and things like that. But now that we have all this extra space and rooms, we had some new fun toys that we were able to add into our office. So excited to bring the Ovitz on board. And we've had a chance to do a lot of scans with it. In a nutshell, and again, I'll let Troy touch on this a little bit more on the lab side in just a moment, but basically, I would summarize this in this way. I think it was John Gellies that did a study that basically looked at, I think it was, and correct me somebody if I'm wrong, but it was a double-blinded study where they basically took patients in HOA lenses and patients in not HOA scleral lenses. And they basically just, the goal of the study was, are patients going to like the HOA corrected lenses better, or are they going to be happier with their non-HOA corrected lenses? And I believe that 28, it was either 28 or 29 out of the 30 patients preferred the HOA correction. They might have been already happy in their current scleral lens. Maybe they were 20/20, 20/25 plus, somewhere in that ballpark. But almost every single one of those patients was happier with their HOA correction. And the only patient or two that were not, they still actually said that they saw better. They were just a little bit upset that they lost a little bit of near vision, and that was their only reason that they were had a complaint over that HOA corrected lens, because that is going to potentially get rid of some of that, in our keratoconus or irregular cornea patients that could benefit from the multifocal optics that their cornea provides. The HOA correction will reduce that a little bit, but everybody else, 28 or 29 out of 30 preferred that HOA correction. So, it's hearing things like that gave us the confidence to say, there's probably going to be a lot of people that would benefit from this. I mean, for years, we've got plenty of patients that are 20/20, 20/25, some are 20/30 or 20/40, and we don't have a great reason why they're not seeing better. So we kind of make the assumption that it's from HOA because we've evaluated everything else. The rest of their eye is healthy, their nerve, their macula, their lens, there's no cataracts, right? So, assuming all those other things are good, why is it that some of these other patients are just not thrilled, or they're not having perfect, as ideal vision as maybe they should be? And so the Ovitz gives us a way to measure that, and it gives us a way to predict if that patient is likely going to have enough benefit to make it worth it. Of course, we tell people, right, we can't predict the future, but this isn't a way to better and certainly more perfect or get more perfect the optics of their eye. And the key here is having a really, really stable lens. You don't want to measure HOA in a lens that's rotating. You don't want to, you know, that's probably the most important thing for this is the lens has to be finalized and it has to be stable. So for us, we're still able to get screenings, right? We know that although the lens may not be perfect, we're still taking if it's a new patient, right? And we're putting a trial lens on them in the office. Once that trial lens, the best fitting trial lens is on the eye, assuming that it's pretty darn stable, we take them over to the Ovitz and we get a screening photo, and then we're basically looking at two things. Number one, well, three things. Number one, what's their best corrected vision just in the scleral, and what's their happiness level with that? That's probably number one. Number two is what is their total HOA RMS, their root mean square of all of their HOA. I think Ovitz has some data, some norms that they look at, and off the top of my head, I believe if the total HOA is above a 0.6, that would be very significant. Actually, if it's above a 0.3, it's flagged as significant. But if it's above a 0.6, there's a pretty good chance that that patient is on the right track for having some pretty significant HOA. And then the second thing we would look at is the all the different types of HOA that are going into that. And the person that's going to be the most successful, most likely, is if they just have one or two very significant types of HOA. If they have 10 different types of HOA that are all about the same significance, it's not that it can't be corrected, it just becomes a little bit more complicated. So as far as we've seen so far, the kind of the slam dunks when we're showing this to folks, if they may or may not be interested in adding this to their lens, is, hey, here's your total error. This number, which they highlight in red, so it's really easy for the patients to see and understand, is high, right? That's number one. Number two, we show them kind of the spread of all the different types of HOA. If there's one or two of them that are off the charts, we say, boom, this is pretty slam dunk. You're gonna likely benefit from this. And then there's some other cool functions on that Ovitz machine where you can actually show the patient, or it shows the patient that it's at least showing me an estimate of what that error looks like. So there's some kind of fun tools and things in there, but right out of the gate, that gives us a great tool to, even with the trial lens set that may not be perfect yet, it gives us a pretty good idea of the total amount of HOA, the type of HOA, and if it's someone that probably would benefit from that. So that screening, you're not on the hook for anything, you haven't ordered anything, that's just really information for you, the practitioner, on the front end, and it gets the patient thinking about it, right? So this is a nice tool where you've already kind of put that in their head that, yes, the scleral lens, it's going to make, you know, maybe it corrects 90, 95% of their error, but maybe there's 5 to 10% remaining. Maybe there's 3% remaining. We know all of our patients' needs are different. We've got those 20/40 patients that are happier than all get out. And then we got those 20/20 minus patients that are throwing things at us because they just can't get over that glare that they see around headlights. And this is that next step. We've been talking about it with patients forever. So we had actually compiled a list of people that when we got this, we started calling folks and saying, hey, guess what? We talked about this for the last 2 years. We finally pulled the trigger. We've got it. Now we can do something about that extra halo effect or glare doubling that you're seeing. So that's kind of my my spiel on how it works. And again, I'll let in these last couple minutes Troy talk about their process. And the last thing I guess I'll leave you with while I'm thinking about it is the term higher order aberration and error doesn't really always resonate with patients, right? So I think, you know, I love analogies. I get my patients, you know, they make fun of me all. I got an analogy for everything. You know, I got my cataract, my cornea analogies. I got, you know, so for HOA, I think the way that I would explain this to patients, because if you start saying things like, well, you know, we have myopia and astigmatism and then spherical aberration, you start saying stuff like that, you've already lost people. So the way that I will kind of explain this is I'll say, you know, your cornea basically is noise, right? An irregular cornea, you've got all this noise. The noise is in a certain direction. A scleral lens sometimes can reverse that direction. So even though we're quieting the noise, we're reversing the direction, and that creates a different kind of noise. And I like to explain that as, imagine that you go to sleep every night with a sound machine, and that sound machine is set to a pitch of a D. Well, you've done that for years, your brain's used to it, you go to sleep with it, no problem. Well, at some point someone says, let's turn down the noise on that sound machine. Great, but what happens if we change the pitch to a C? The noise might be less, but it's going to drive that person nuts because they're used to a D note and now they're hearing a C note and they can't unhear it, and the brain doesn't like it. And that's kind of how I would summarize what's happening when we've reduced the noise, we've reduced the blur, the error on the eyeball for that patient, but we may have unintentionally changed the pitch, and so now they can't unsee it or unhear it in that example. And so I think that's kind of how I like to explain that to patients, and that seems to resonate pretty nicely. So hopefully that makes sense. So I'll hand it over to Troy, and he'll kind of talk you through how the Ovitz HOA process works on the lab side of things.
All right, thanks, Dr. Gibberman. If you can go to the next slide. I just want to kind of convey and let everybody know there's going to be prerequisites when it comes to trying to utilize Ovitz and correct HOA. It's pretty straightforward, pretty simple, but it is still required in order to get the best outcome. So what you need to do is first off, HOA is only available in the Maxim 3D, and we also want to stress the fact that there needs to be a certain amount of toricity within the fit. Right now, minimum from our patient sources that we currently have fitted in this product is about 200 microns or more. So establish the fit in a Maxim 3D lens. It's important that when you establish the fit, there's no rotation, there's no movement, and the lens is stable, and the patient is comfortable, and there's not going to be any more adjustments to that fit. Once that happens, under the current warranty, AccuLens will send out an Ovitz trial lens. That particular trial lens is specific to Ovitz and is specific to the system having the capability to capture that pattern when the lens is on the patient. It's going to provide the best position when Ovitz goes to make the correction on the front surface of the lens for us. So then you take then once you get the lens, you scan the patient, you send the data to Ovitz, and then AccuLens and Ovitz team together to create a final lens. On the back surface, it'll mimic what you have fit the patient in successfully. On the front of the lens, the HOA correction is then incorporated during our manufacturing process. Go to the next slide. So the pattern is, like I said, is specific. So when you get the trial lens, what you see on the screen here, the pattern will have to be specifically set on the eye, positioned correctly. So when the system maps that and sends the information back to Ovitz, there's an understanding, number one, that there's no rotation in it, that it's stable. And number two, that when you do take the scan, all the dots are in a specific position, and we're going to accurately create an HOA pattern. So the prerequisite here is extremely important. Establish the fit under current warranty. If the patient requires an HOA correction, then go ahead and order an Ovitz trial lens from AccuLens, and that's sent out at no charge under the current warranty for Maxim 3D. Once you get that lens, then you go through the process of scanning with Ovitz. At that point, once you've made the decision to go ahead and order an RX lens with the HOA correction, then what we do is we start a new warranty. So basically, you're into a new product. And so that warranty, again, goes another 6 months. So you have the capability of making slight adjustments to the HOA. And that goes through 6 months, because there's going to be some times when you also still have to make a slight tweak in order to get the lens to stabilize. So I just wanted to make sure that everybody understands that it's there are prerequisites to it. You have to make sure that you follow those in order to get the best outcomes. Because if we don't, we've seen some issues with it. We've seen some failures in it, and we don't want to have that happen. I think that covers it.
I think you may have mentioned this too, but you know, it's almost expected, right? Like you're going to likely have some when you put those HOA changes in a lens, you're probably going to have some over refraction changes. So it's a good idea to let the patient know on the front end, this is likely going to take a few corrections, right? And that's part of it, right? So there's going to be some back and forth, a lens or two ordered, because even if their overall vision and all the HOA goes into the lens perfectly, if their prescription changed by a half step or 3/4 of a step, certainly they're gonna, if you don't tell the patient that ahead of time, they're gonna put that in and be like, what happened, right? So just patient expectations, and communication, right? I mean, it's the same thing we deal with all the time. The more you communicate to your patient what they should be expecting every step of the way, the more successful you're going to be with all of this.
Yeah, and that's the main reason that we extend that out to 6 months when you order the first Ovitz RX. We understand that it's not going to be 90 days or 120. It could go a little further until you get this patient the correction needed. So it's kind of we teamed up with Ovitz, and we just wanted to make sure that we're going to get the best success out of it as possible. Back to you, Alex.
Actually, Troy, I'll cover this one. This is a special March Madness offer that we put together to give folks that have not had a chance to try what a dynamic, exciting, great design Maxim 3D is. And this is a super low price point. So please don't talk to anybody about it. I don't know. That's crazy. You can talk to anybody you want about it. But what we're offering is a 6-lens bank. That's technically three patients, and you get 6 lenses for a measly $500. That's over $1,000 savings from our regular bank price. And you get a 60-day window to fit 3 patients. So if you're interested at all, if you've been excited about what you've heard tonight, Dr. Gibberman, Steve, Troy, this is a really cool lens, and I would encourage you guys to consider jumping on this crazy promo deal we got going here. If you're interested, you can simply email me at tomschoen@AccuLens.com and get you up and running as soon as we can. And this price point's not going to stick around very long, so take advantage of it while it's here. Yeah, this is an exciting opportunity. Hope you see it. Hope you take it. Okay. Any Q&A? Any Q&A?
Yeah, love to take some questions. I don't know if maybe people, I don't know if anybody is checking the chat or if anybody wants to chime in.
Well, there was a question from Amanda Petiwi, and also a question from Frank Dielmansig, I believe. If I pronounce that reasonably close.
There was a question on lens settling, which I did answer just to make sure I answered correctly. This question comes up generally in scleral lenses, and a lot of people have their kind of opinions on how to do it. The reality is all the lenses will settle, as we all know. My approach to fitting lenses, I don't want to spend a lot of extra time letting the patient settle. I'm not a believer in putting a lens on and putting them in another room for half hour, 45 minutes, and then looking at the fit. We can pretty much assume that lens is going to settle about 100, 150 microns. So we put the lens on, evaluate it, and I want to have a little extra room there to account for that settling. But my goal is always to get that initial lens so that the patient can wear it. They can go out the door, enjoy the lens, experience it for a week or two, and then at follow-up, now that lens has absolutely fully settled because they should have worn it for 2 weeks. And when they come back in, it's going to be on their eye for a few hours. That's when I'll actually do my fine tuning and assessment at that point. So hopefully that answered the question about settling.
Okay. Well, those are the 2 questions we had. Anybody else have a question? Just.
There was a question that we were able to answer for any of you that are international, not domestic here in the U.S. We do have a specific distributor that more than likely would be able to get these lenses to you, and also set up individual training. So please reach out to Tom on his email, and we can get you set up and give you all the information that you need.
Guess we did a good job of covering everything. No other questions.
Sounds good.
That's what it seems like. Alex, thank you very much. You did the yeoman's job tonight. Appreciate it.
Yeah.
Steve, always thank you. Troy.
Yeah, thank you everybody for attending. I'm glad to see
Yeah,
you.
thanks for tuning in this evening, everyone, wherever you're listening in from.
Yeah. Okay.
Thank you, and have a nice night.
I'm peeling off. Good night, everybody.
Yeah.
Take care.